Greetings, cyberspace. Another exciting year has passed. It has been a very challenging, a very interesting one, and has brought us to unite more than ever. Now, the cybersecurity month returns, as is every year. This is something that we can't stop, and we shall proceed. The CERT.LV has been busy, as you all know, and I would assume that every single one of you has been busy for the past year. And this is not going to stop, since cyberspace is not going to sleep, and cyberspace is here. 2021, this is the year we are running our annual conference, Cybershock 2021. Now, 21 is a lucky number. It's a lucky number in gambling. It's a lucky number for trying out your luck. It's a lucky number if you win. In this conference, we are going to pursue both parts, what happens when you win and when you lose. In the cyberspace, how do you track cyber criminals? How do you track whatever happens on your networks? How do you take advantage and win to get control over a target systems or target resources? This is all that we're going to explore in these upcoming 2 days. Now, this conference has been truly a community effort in finding speakers and allocating speakers and approaching the speakers. We offer you a selection of 8 exquisite technical talks across the 2 days. Today we will have 4 talks from today, right now, up until 6 o'clock, 1800 in this time zone. Now, in this conference, we have more than 900 registered participants, which is a really huge number when compared to all the previous conferences that we've done. This truly shows the power of the community, the interest of the community, and we are here for you. While we are already here, at 9 o'clock early this morning, the CTF Capture the Flag event started with around 31 teams with 108 participants striving and fighting for the battle. Who is going to be the best team out there? There, we already observe a very tight competition among 3 teams, even though we are not going to disclose the information to keep the suspense high, and we're going to start revealing this information slightly tomorrow and maybe today towards the end of the conference. Now, this conference and the CTF would not be happening without our long-lasting partners. I would like to mention only a few of those. The Cybershock Technologies and CTF Tech from Estonia, who are offering the CTF content. TET Group from Latvia, who is providing the platform for the CTF. And of course, our partners, CyberCircle, who is offering the prizes for the first 3 winners. Now, with this introduction, I would like to introduce our first speaker. Our first speaker for today is going to be Mikael, a huge expert in his field, and his field being focused primarily on industrial control systems and honeypots. Mikael, with this, I welcome you here to the stage, and the cyberspace is yours.
Excellent, excellent. Thank you very much, and hello, cyberspace. It's a great pleasure, and I'm really, really happy to be here. Just for the sake, are you able to see the slides? Oh, thank you. You know, that's part of being able to sacrifice to the demo gods at the right place. And I got absolutely not nervous when I heard there was almost 900 attendees to this. So thank you very much. As introduced, my name is Mikael. I would like to take this session and give you some insights on how to run high interactive honeypots in a red and blue teaming environment. Here we go. First, a bit on myself. My name is Mikael. I originally come with more than 2 decades of experience within traditional IT security, within pen testing, within audit, and within business continuity preparedness. After 2 decades, I grew very, very tired of finding stuff that people should have fixed a long time ago, write them a report, and then come back next year and write them another report, just with some new vulnerabilities on that. So for the last 8 years, I've been working exclusively within industrial security. So that means that's all the small things, all the system that actually runs our society, everything from energy to transport to water and a lot of other different things. I've been on a lot of different classes. I had a lot of things, but this is actually not the part that is interested in this point. During my career, I've been assisting with responsible disclosure to a number of different vendors, ranging from everything from Siemens to ABB, Honeywell, and a lot of other things. And as one of my friends said, I'm a really lazy pen tester, because that sometimes I'm the living proof of finding vulnerabilities in such systems is just way too easy. So that's a little something. So just to give a quick brush up on what's actually this guy going to talk about, and I'm going to give you a technical presentation on how to do high interaction in a red and blue team training environment. The same would be on my favorite topic, that would be ICS. ICS stands for Industrial Control Systems, or OT, which would be Operation Technology. Those two terms are used interchangeable in this presentation. And just to say that even if you said, hey, I'm not working in a critical sector, what's in it for me? Most of the stuff is something that would be directly adjusted into traditional IT enterprise systems. So, and I will give some of the benefits. First of all, introduction, like what is industrial control systems, what are honeypots, and last but not least, how can you actually use them in a training environment, and how can you use them in like real environments. The presentation is scheduled for approximately 45 minutes, and there would be 5 minutes allocated to Q&A. So if you have any questions, enter them into the chat or enter them into the Discord channel, and we'll see and answer as many as possible. So don't be shy, just fire away. A short overview on the difference between some of the things. IT, as you know, it handles data. When we are looking into IT security, most of the purpose, or actually the sole purpose, is protecting data. We don't have that much what happened with the hardware in itself. We just, reboot, reinstall, burn it, whatever. But the data, that's what we really are interesting. That's a big difference between that and operation technology security, because that's where we actually want to ensure the process. Just imagine if you're manufacturing pills or water, you really don't care that much about security. Per se, you are really, really interested in that you keep delivering whatever kind of service you are, power, energy, water, transportation, and so on. ICS, Industrial Control System. SCADA is very often like the system that, in example, keeps the power grid together, and you can see what's going on there. And as mentioned, the purpose of industrial security is the ability to the facility to be secure and operate. Whatever you want to do, you don't want a patch suddenly makes the light go out in the morning. So, very often there's a lot of myth about industrial security, and very often, like, this thing is something that it can be patched, can be down, and I call them myth because that sometimes there's a grain of truth, but things are getting better. But the big problem, or the challenge, so to speak, between those kind of systems is that if you look on your average computer or phone, it's probably like less than 3 years, probably. Then if you look at the typical manufacturing systems like milk production, something like that, then you very often have something from 8 to 10 years span time. So that means that when you deploy this equipment are going to last at least for 10 years. That's an expected lifespan. So basically you would have just imagine now how many computers you would have in the lifespan of 10 years, or even phones. And again, the 3-year thing of updating laptops, for whatever reason, it doesn't go for teenagers. In example, my son thinks that each certain month he should have a new computer. That's a whole nother thing. Then, ladies and gentlemen, if you look on the right side, then we have a sub-power station. And there's nothing particular with that, but in general, the whole thing on the lifespan is that such things are going to spend at least 20 to 35 years old. Today, I'm more than 45. During my life, I've actually been on substation that was approximately the same age of I. And taking that from a security point of perspective, because the things run, we have a very high reliability of power, we have very high reliability of water. So from a technical or security point of perspective, what's actually the problem? It's very easy when we do something like that. Again, if we take into the laptop that's 3 years old, you're probably, if you don't running Linux or Mac OS, you're probably running Windows 10 at least. If we look into the system that was, from 8 to 10 years, then it's very likely to run on Windows 7. And then, as you and I know, the shift from Windows 7 to Windows 10 gave us a lot of security improvements. But just imagine if you're then running Windows XP. And again, it's run there because it's very, very reliable. And also because, quite frankly, a lot of people are, afraid of doing anything that can make it trip over because you don't want to cause a power outage. So just imagine for the audience that might be on the same age of I, just imagine that all the things you could do with an XP, it was a whole nother ball game that on Windows 10. So basically, that's you very often you on this kind of system, you try to isolate them, you put them into separate networks where they can't talk to anyone themselves. And of course, there's a lot of other safeguards, but that's some of the thing. During my time, I said, okay, what's also quite interesting for industrial systems are that they're extremely stable, but it's also they're extremely predictable. If you consider how your normal IT environment are, you've got clients, you've got servers, you've got things that popping up running DHCP and then went off, you've got mobile phone, you've got a lot of different things. But the really cool thing from a security perspective with industrial control systems would be that they're very predictable. So that's also, that server A are going to talk to server B, device X are going to talk with server C. So it's very predictable. And that gave us a lot of opportunities. And why am I coming to that? Yeah, it's because that just like industrial control systems are very old, I would like to introduce you to the concept of honeypots. Honeypots is by no means new. It's also almost like also got 2 decades of age. But there's a certain thing why I think honeypot are extremely interesting, both in traditional IT enterprise networks and in industrial control systems and other kind of industrial networks. Again, it's very, very predictable. One thing you don't do in an industrial network is that you don't scan for things, because that even in some cases it's an urban myth. Sometimes if you're doing something simple like an in-map scanning, some of the equipment you would just tilt over and die. So basically, it's very, very stable, and you don't have a lot of new things. So, just a quick question on this. As you can see, it's a mock-up from an in-map scan, and basically, if you look at it, there's no really difference. Well, the only difference is like the MAC address is different, but otherwise we can see something we have scanned. Port 102. TCP is a port sometimes used by very different vendors, but in this case, it would be a Siemens PLC, which we also can see based on the MAC address, because you can see it's a Siemens thing. A Siemens PLC, or PLCs in general, are just to make it's very high level. It's industrial computer who run probably just one single thing, but they're extremely good at it. So that is what, making the train go on time, and that's what drives the energy, and that's what's brewer beer and other, really critical things. So looking on that, there's really no difference. Is that true? Nah. However, if we do it something like now, you would be able to see there's quite a difference. As you could see on the upper side, there's this is Siemens. This is how a PLC actually looks like, a small industrial computer. On the lower left side, it's a MOXA. It's an Ethernet to serial port. It's something you use really in a lot of places where you have really old equipment that don't know anything about TCP, IP. It doesn't even have perhaps an Ethernet port. So that's a device used in a lot of different places. And then last but not least, of course, it's a ruggedized mini single board computer where you can run a Honeypot in. So in this one, you can actually see part of the Honeypot is to make something, deceptive and believable. So just to sum up the Honeypot, it's a practical security approach. The really good thing about it is that having a Honeypot, if you have it one of the good ones, then you would be able to learn more about the attackers, the way they attack. You can get a lot of intelligence. But last but not least, especially in your own environment, one thing is that you might put up a honeypot on the internet and see who's scanning and who's doing what. That's one thing. But the real value shows when you put up a honeypot in your internal systems. Because the sole purpose of this honeypot is that it should never have any type of contacts. Nobody should ever contact it. So very often there's this from different numbers, like how long would an adversary be in a network? Most people say this could be anything from 67 days to 110 days. So this is, an early warning. This is also why it's sometimes called a canaria. As you can see, the guy on the left-hand side, it was like back in the old days when people came into the mine. If the canaria just suddenly tipped over, something was wrong, we need to go, we need to do something. And it's exactly the same thing. Honeypots, again, are able to mimic or simulate a lot of different equipment. Some can be IT or industrial networks. A good example could be it could be anything from when you're doing an Nmap scanning or other kind of things. It's say, hey, I'm a printer, I'm a HP printer, to yes, I'm a Siemens PLC. So basically that's, again, if you said, well, the honeypot seems to be a cool concept, but what is actually the benefit? Because I already have next generation firewall, I have intrusion detection, I have endpoint detection system, I have everything. And again, it goes without saying there's no single silver bullet to security, but it's a really good tool to have in the defense of that. The honeypot, you really never should talk to me at all. It can be put into a network drop-in. The only thing you need is that, to have one or several IP addresses allocated to it. And the good thing is what I like to see, it's like it has a zero false positive. It might be once in a while, it comes with an alarm, but each alarm would either mark a misconfiguration, a mistake, or an adversary. A good example was once when I was working in an environment, we just deployed some high-interaction honeypots, and one of them fired off right away. And then after we was investigating a bit more, it turns out it was one of the engineers who was fat-fingering IP addresses. So what the engineer thought he was trying to configure one of those devices actually turns out to be the honeypot, and then it started, a lot of red lights, and it was very funny afterwards because we immediately, of course, assumed that they had a breach. Another cool thing is that it shouldn't alarm at all. So you don't have this, I don't know if you have done that, but I've been working in a SOC when I was younger. And, if you're just getting this deluge or fire hose of alarms, once in a while, even the most skilled analyst would once in a while miss, small indicators. You're not supposed to do that, but we anyone are human. So, and we just have a certain level of capacity of remembering stuff and evaluating things. So, again, each interaction, because I was not supposed to talk with them, give us an alert on that. Honeypots comes in different forms and shapes. I'll just really fast run through the different types. The low intersection honeypot, basically it's just a dumb listener. It's just like a TCP UDP listener. So it can say, okay, somebody is trying to communicate, we just give them some bogus reply back. But in reality, a real hacker would not really be fooled by this. Low interaction honeypots are really good for just if you're starting to get your feet wet in this area. They're very, very easy to set up. And also for unsophisticated attacks. An example like malware who's scanning the network, such like that would immediately fire up on that one. But again, a skilled attacker would very, very soon be able to find out this is not the real thing, and he or she would move forward to other more juicy targets. So again, and you don't have a lot of forensics capacity because basically you can see IP XYZ was talking to the honeypot and it did it 3 times. So again, early warning, but nothing more than that. Stepping up a bit in the food chain is that when we go to the medium honeypots. A medium honeypot is stuff where it's actually schemed that you get more things. That would, an example, be that when people try to log in, an example on a telnet, then they actually get a telnet banner back. You can fire out commands, you would get some kind of interaction back. So this would initially seem for the adversary to be the real thing. It goes without saying, and that goes for all honeypot, that the length of deception, eventually stuff would end. That goes without saying. But the more interactive they are, the better they are, the more time the hacker would spend time on target, and again would give the blue team more and more time to actually start scrambling and doing appropriate counter actions. So it would have more like remote probe from the adversaries. It would, if configured it right, it would provide some visibility into the different tactics. Would this be an example? Okay, we see this type of, especially if you have internet deployed things, then you would be able to see, okay, this IP address are scanning for this type of thing. And it's very, very interesting. If you're looking in an example, we have a global deployed honeypot network with more than 180 devices. Whenever interesting stuff are happening in the industrial space, we can just suddenly see a sparks of scannings. And sometimes we see the spark before it's actually known, so we can say, okay, we know somebody's onto something. But again, even a medium honeypot illusion would not last forever. So you need to take further steps in that. Last but definitively not least, the high interaction honeypot. The honeypot is where it actually says and acts like the real thing. You might even want to have what we have done in a number of deployments. We have several honeypots, and then they are proxying into a real device, because that means that it's just acting as the middleman. So you would capture all the traffic, all the commands, all the things that the attacker are trying to do versus the device. You would get even more knowledge on it. You would get more TPTP. And again, you would be able to have the adversary in the illusion for the longest possible time span. Again, back to, I would much rather have an alert from the honeypots rather than somebody knocking on my door and said, hey, Michael, you've been compromised. Congratulations. So it would also, again, give the blue team appropriate time to respond. It's definitely not much time, but at least it's better than having FBI call your door and said, hey, you have been owned. That's really good. Again, why is high interaction honeypot interesting? First of all, especially when you look into the industrial equipment, it might be really, really hard to source such devices. There's a lot of regulation based on them. And if you're able to get such a device, it can be really, really costly. I can say it upfront, running such a thing, it's end up to be a very costly hobby, so to speak. So, again, a high interaction honeypot, how should it actually work then? Well, first of all, the honeypot that we're currently using has the ability to be basically whatever you would like it to be. So that means that if you're doing Nmap scanning, it would come out and say, yes, I have this IP address, this port open. So the interesting part is that if it's been configured correctly, then something like NSE, Nmap scripting engines that can get even more information, are actually working as intended. It would be cost effective because you can run very a lot of templates on the same device. If we take something like a Raspberry Pi, an example like a Raspberry Pi 4, you would be able to run, let's say, 5, 10 templates, or how many you would like, basically. And it doesn't take a lot of horsepower to run, so it's very efficient. So, yeah. We have the saying that we have the 3 strikes before you're out. And what do we mean with that? Yeah. First of all, it's we mean that it should give the right reply when looking at a MAC address. I've been looking at very many other solutions, and I'm also, getting really tired in my head whenever I'm scanning something and said, yeah, I'm an industrial something, and then the MAC address said, yeah, I'm a Raspberry Pi. No. That's just that's one of the myths, that honeypots don't work, and honeypot will work, but of course, just like everything else, it takes an effort actually to make stuff work. Another thing that's really important is that if you use the Nmap-O, which is for the operation system, it should give the right reply. Again, you don't want to see something extremely special equipment and say back, oh, by the way, I'm a Raspberry OS something. So that's also something you need to take into account. Again, back to like honeypots, you need to be them as deceptive as possible, because otherwise it's just basically a waste of time. I have ended, for you how known with the industrial security, I put in some of the tools that you normally work with. Something like PLC scans, it goes without saying, it scans PLCs, it can come back with a lot of really interesting information. So of course that if you know such tools are being used, then you should accommodate for it, you should configure it, the honeypot, so it actually works. And then last but not least, remember that each and every interaction should raise a red flag in your SOC or whoever are looking into that. It goes without saying. And the cool thing about also, we talk a lot about shortage of manpower. Things like this, things like honeypot, is something you can put your most junior analyst to actually look at, he or she, because again, back to, you have something where they definitely never ever should say anything at all. So if you have any time of communication, that's a really big red flag. Again, in IT environments, we once in a while have this asset inventory requiring something, and then you might get some flags. Then go in, just whitelist and said, well, we know if that come an example from our Nessus scanner, this come from our asset inventory scan, this come from blah blah blah. Just remove those. This would be false positive. But again, then whenever something else are communicating that it shouldn't, then it's a good time to do something. Because either I'm a really seasoned security expert or a scary cat, I put in a link where you can see the honeypot in action, because doing this live in front of 900 people, it's in that case, I'm getting a bit scary cat. So if you're interested, go in and see the video again, and also explain some of the finer grains in more details. Cool. Some practical example on how to use honeypots. I've been very strongly engaged in a security conference called CS3. And as you can see, there's a lot of cool industrial equipment there. We are a bunch of people who every year comes with all the junks we have from the basement or from a garage or whatever we have been able to borrow or get from our respective employers. Because very often such things, again, it's very hard to get fingers on. So Then we have for 3 days in one of the rooms, we have all this nice equipment up. People can come in and then they can try to work with them. And it's really, I think it's really interesting because a lot of security experts comes and said, well, we have this kind of equipment, but due to budget cuts, we got it in production, but we don't have one single piece of doing that in a test lab. So we're not actually able to scan, we're not able to learn anything about it. And the cool thing about such network and the whole idea behind it is you can come, you can do whatever you want to do within certain limits. Of course, we don't want you to come with a forehammer, but otherwise you can do a lot of things to the network, and you can do some things that you would normally never do in production. So you can come in, you have the ability to learn, to interact, and very often, I can't remember, we have run this for 5 years straight, I can't remember one single year when we didn't pull at least 1 or more 0 days out from the equipment, and then did responsible disclosure to the vendor. So that's the thing. So some of the years we have put up high interaction honeypots, and we told people, hey, on these 4 particular networks, we actually do have honeypots. Come on, spot them. We added a $100 gift card for the team who came close. The best record so far is like 75%. Some of them was really, really easy. Just imagine that you had the 2 seasoned persons sitting and scanning the network, and one of the IP addresses said, oh, hello, I'm a Sony PlayStation. It goes without saying that a Sony PlayStation is not something you expect to find in an industrial network, so that was kind of an easy flag. Some was much harder. It was when we were starting to use proxy and other things. So basically, you tell that into a system with admin. You tell it into the .99 IP address, but then the display said .100. So you said, hey, that's something wrong. It's very, very interesting to have this. Also in classes, I very often had a specific template I'm very fond of. When it comes in, it showed an IP address of a very well-known product. People logs in, and whatever they logs in with the first time they would get access, then there's a 15 seconds timer, and then it would lock them out by default. And I know there's a special place in hell for people like me, but I really think it's funny when students like the 8 or 9 times are typing in, said, oh, now I can hack it, and then just see the disappointment because they've been locked out again. Of course, real equipment would never do that, but Honeypot does. And again, had this been in a really network, then it would have raised a lot of red flags and, hey, somebody is trying to mess around with our Honeypot. Would you please come and stop them? So, and the last practical example as well, 2 years ago, I was working very close with 2 researchers from a UK university from Cambridge. And basically what we did, we put several networks out on the internet. So it was with really, really lousy security, just like your average system could be. And then we start to sit down, capturing traffic and see. And the interesting part was over the 14 months, we actually had several people, because it was so believable, and some of them was real equipment, we actually was able to gain 4 0 days. So we had the PCAP furl, we then reversed what are they trying to do, and then did responsible disclosure to the vendors involved. That was really, really cool. And that's an example, again, if you have honeypots and you actually put in a bit of effort in that, then you get some really, really sweet, interesting results. So enough on the honeypot, but why not combine that with a safe training environment? We have 2 projects, and we said, hey, if we combine them, we would have twice the fun. So just imagine that you had the power of using real industrial network or whatever kind of system you would like together with honeypots. Very, very often you find a case where you have system XYZ that does have a vulnerability. And you might be able to go out online and search eBay or search all your friends, and you might be able to find it, allocate it, and then get a ship, in example, from the US or something similar. But in a training environment, it's really, really valuable that you have something that can mimic this device right away. In example, like you can say, okay, students, do a scan of this network. There's a bunch of equipment. Tell me out which one is actually vulnerable. Because it doesn't have to be the real equipment, but just saying back, hey, I'm a XYZ type with this firmware release, that should raise a flag, and then the student can then start to compare and see, okay, this type of item is vulnerable, so to speak. It might not be the real thing, but it's good enough for some of the training things. It's built to make. Currently, we can make more than 3,600 templates. So that's the thing. So basically, also now we're going over to the training environments. If we look into the typical problems, I love taking security classes. If you have an IT security class or OT security class, I love to be there. I'm putting a lot of my money with the SANS training organization and ICS and a lot of other places. I love it, love it, love it. But it very often tends to be very, very intense, let's say 5 or 6 day classes, where you have very, very little time to explore stuff on your own. So you have all the fun and the cool hardware. It's been left behind in the classroom. It was actually that type, so I had to go out afterwards and buy real equipment for me to find some vulnerabilities afterwards. And that vulnerability ended up to be known as the CV number that is being put here. So you also might have that the long time absent. Oh, sorry, 2 seconds. It might also be that the week-long absent might not be very good for neither your work, your manager, your spouse. It might not really be appreciated. So, but that's a whole nother thing. Very often, it's not possible to recreate the lab setup, and it can take a ridiculous amount of time to get configured, and because that you have a lot of proprietary special software. And it's very often, it's really a mess to get hold of that. Most of the offerings, with a few exceptions, it's a very one-side training. With that, I mean, you have like exclusive red team testing. You're just learning how to do pen testing. You might have on the other side, it might be only blue team defense. And just to quote Sun Tzu from the Art of War, in order to know your enemy, you must become your enemy. I always think that the best responses and the best people all around profiles are the one. If you're working with blue team defense work, you need to know some of the tradecraft from pen tester from the red team, and vice versa. If you're working as a pen tester, you definitely need to know something about, okay, what kind of capacities does the defense systems in order, what's the best way in order to trick IDS system, in example. So cool, and that. So with that little introduction, I would like to give some insight on the ICS range. It's basically, we said that, well, whenever we have all this really, really nice equipment, why not make it available as a service to people? So basically, you can sit in your comfort from your home or from your couch, and just whenever you have time, actually starting to do some of the things. We are looking into one of the concepts is that it doesn't require any special software to be installed. We have all been there. Try to go down to your local IT or IT security department and say, hey, I just need to have VMware installed. I would like to have some Kali, some OpenVPN, and also need a PuTTY and some other equipment. Very often, this would be totally no-go on corporate machines. Of course, you can use your own, but again, it's running around with different computers. It's just messy. So for the initial use, you just would be a remote desktop. On some of the more advanced tasks, you might be able to use SSH. But again, it's software that's really not really hard to find. Then you have video and text supporting material for this. So again, What we aim to do is that a purpose-built OT environment with the different levels based on the student skills, because that we have a lot of different type of students. So if gamification is your thing, like sitting together with your co-workers and trying to hack each other and doing capture the flag, if that's your thing, that's cool. If you just want to do casual learning, that's also your choice as well. And then different backgrounds require different setups. And with that, I mean, if we look on the top right corner, the people who are sitting with blue teams, they have certain skills and abilities, but they might require some knowledge on the team on the red side, as mentioned before. Again, if you're looking and working as a red teamer, you might want to know something about the blue team. And again, since this is equipment that often is really, really hard to find, then yeah, it's interesting, because I don't know that many companies when your manager said, oh, it's not a problem that we're spending probably something like 30 or 40,000 euros just to go out and buy your different hardwares. Go do. If you have that kind of manager, be very happy, because they're really, really rare. Another case is people who's using as an operator, because very often it's my understanding that when people start to see how easy it is actually to exploit such equipment, if you're working as an operator, you have like the IT security people who come, they're just, centers from hell, because all they do is like making your life more miserable and make it much harder. However, it's my experience that whenever I had people with operation background in this kind of environment, they suddenly leave and said, okay, we could actually see equipment we actually have home in our own station or our own facility. We can actually now see how easy it is to hack. So now we actually understand why the IT security guys are want to do such things. And then last but not least, it comes to my knowledge that if you're working as an architect, I know of very, very, very few classes that actually teach people how to do architecture things in critical environments. And we would also have, some task in this matter as well. So because that when you're doing architecture, you can do stuff in a lot of different ways, but there would be, example of what's really good and what's less good. Of course, now I normally, when I do this presentation in physical, I can now hear one of the guys or girls from the audience said, but I can do all this stuff myself. And I said, you're absolutely right. If you can do that, it would be extremely good learning experience for you. A bit ironic, I put like, this is a starter pack, so you can go out and buy this. Happy hunting, go do. But again, getting access to real industrial equipment, that's a pretty expensive hobby. And again, a lot of managers would rather prefer you actually doing training right away, rather than spending, in example, a week or two in configuring some of this equipment, if you can get hold of it in the first place. So, a few examples from the lab before we open for question. Again, if you're sitting as a process engineer, then security is not what you really have been exposed to a lot. For a lot of people, using stuff like Nmap, it might be for you and I, this is ridiculous, simply something we have done for many, many years. But just imagine the light on a security engineer, process engineer, when suddenly said, oh, if I can do this, then I actually can try to find equipment. Oh, so if I do this, oh, I can see this is a MOX device, an example. I can see this. Oh, it actually kind of perhaps tell me even the firmware. So there's just a lot of different scenarios when seeing is believing, and especially in this case, it's good. And of course, it goes without saying you don't want to do Nmap in your own production environment because stuff might break. So that's one thing. So a typical task in this would be on this specific network segment, find all the vendors of XYZ and tell us the associated IP addresses. That's very simple for experienced technicians. For newcomers, this would be an eye opener. Then another example would be lab example number 2 would be where you actually have a real firmware provided. This could be an example like a red team scenario where first you are going to reach a FTP server, again placed on a honeypot, and then you can breach it, and we could use different versions, different vulnerable versions of the FTP server, also in order to make it as believable for the training environment at all. So, and then you would download the firmware, and then the task would be to get this real firmware, reverse it, and then find the undocumented user credential set. And just as curiosity, I can tell that when we found this vulnerability, the 0 day or whatever we should call it, we did responsible disclosure to the vendor, and half a year later, they came back and said, "Oh, this is a remote support feature. It's not a vulnerability." I don't know what you would call it, but I would definitely call it an undocumented backdoor as well. But again, this just showcases the state of some of the security. And it's sometimes it's really, really interesting. And then last but not least, on the word of interesting, this would be one of the more the creative or harder things where you actually need to do some more work. This is where we are going to duplicate elements from the Ukraine 2015 power grid attack. For you that are not familiar with this particular thing, is that in Ukraine 2015, there was, to the best of everyone's knowledge, the first at least documented attack on a power grid in a nation. It turns out there was 250,000 who was lacking power for some hours. And in this specific topic, which we had a lot of insights in, is that you need to research the event. There's a lot of documentation, also a lot of technical documentation around. Then you would, on this particular network, you would be able to find the relevant devices that would be applicable for this type of attack. Then you would do even further research. You would probably have to build some codes or recompile different stuff. And then last but not least, the thing you would get access to it, and the flag would be able to update the device with a new firmware. Again, as you can see, we take a big pride in it would going to be like real life examples. The vulnerabilities I've talked about here is something that actually was again responsible disclosure 1 year later. It was back in December 15. As you can see, 1 year later, the firmware who actually fixed the problem came there. So again, if people are into casual testing, that's one thing, and everything is built up on the capture the flag software. So regardless if you do casual gaming or if you do gamification or whatever, you would have different means in order to do so. So with that, I would bring back and say very much thank you for your attention. And I would open the floor for any questions, if
Being here with us and presenting the work that you're doing. I indeed have questions to you as well, collected from the audience that was listening and also from my own experience. I'll try to kind of merge this together. Now, not always you require a hardware to run an ICS honeypot. You might require just the software. However, the question is, how do I design the template, or is there a repository where I can already acquire a template and use it in my production or in testing environment? Do you host anything like this?
I don't do myself, but however, I would say if you look into GitHub and look into projects either like Honeypots, which is run by a bunch of my good friends from the Nordics. Again, that would be a medium-sized honeypot. Or if you look into, it's a really, really old system, but something called HoneyD. HoneyD has some of the abilities to do this as well. So that's how to get some of the honeypot device. And of course, in order to make it as a believable template, of course, it goes without saying, having the real thing is the best. But also, just simple things as looking at the vendor documentation, that would give you an idea of what kind of service and port should be open.
Right. You mentioned that we have to make the honeypot as believable as possible. And scanning is typically not advised. So to lead an attacker towards the honeypot, there would be a requirement to have some legitimate data flows. So how would you lead an attacker from one position towards the honeypot? Is there a strategy that you would propose?
Yes, of course, the first, and it's very simple, but sometimes very overlooked in the thing. First of all, it needs to be feasible. I know companies who have said, oh, we have this really, really advanced industrial thing, and we have placed it on our enterprise network. It's just like, that's really not very believable if you're a skilled hacker. That's one thing. And then mimic different, because normally you have like something called the Purdue model, and you have like different things in different sectors or zones, and ensure that whatever you based in that zone would be feasible. Last but not least, people have a tendency to go over IT-centric stuff, especially in industrial thing. So the best thing is that if you have some really special devices and Windows 2008, 2003, most of the hackers would start with that. So again, also make it as easy or make it as convenient as possible for the hacker, because there are people as well. If you find three things, two of them you don't have any clue what this kind of device is, and the last one is something you know, of course you start with the good stuff, something you Metasploit or whatever kind of tools might be able to help you out with.
All right. I mean, you mentioned to be deceptive as possible. Now, how do we achieve this? Does this mean that mimicking devices to, I don't know, faking Nmap results, or, I don't know, actually simulating or virtualizing device capabilities? How would you suggest us on like best approach that we could pursue to achieve this?
Yeah, definitely I would go for virtual as much as possible, both because it's more efficient. That's one thing, and also I said that don't be afraid to experiment a bit with things. When I started up, I started with a very limited skill set, both in industrial security, because I was quite new to the business, and at that time Honeypot was now it's getting better. You're getting more and more things on GitHub, and something I contribute to myself as well. But having as many templates in the toolbox as possible, again that make it believable. And then last but not least, use the option, if possible, to actually proxy it into a real device, because that would, from the attacker point of view, be the real thing. It might be it's not a man in the middle, it's just a honeypot in the middle, but again it would say the fields and everything, that would be right. But what this person does know is that every action is being recorded and alerted back to the mothership. So whenever feasible possible, use honeypots, but proxy them into a real device as well. And the good thing about this approach would also be that you could have several honeypots which all proxying into the same device. It doesn't even have to be on the same network. So that's also a good way to stretch your resources as well.
All right. I mean, this is a very, very good recommendation to proxy things through something that you control to a real device, thus giving this kind of a sense to an attacker that they are kind of hammering at the real deal while you're observing everything. Now, within the industrial control systems, stepping a bit away from the training environments into the real production systems, deploying the honeypots, I've heard this is a good thing, right? How many? How do I know how to scale, and how many honeypots, and where, in which locations to deploy them? Is there, and I understand that every environment will be unique. Now, but is there something that, hey, you need to consider this, you need to consider that? Is there something that you would recommend right away?
Yeah, there would be. Of course, you said the obviously said it depends, and that's the bullshit answer. But I would like to go more in depth with that, because it's a really good question. I would say whenever you have a network where you either have some kind of external access, very often you have the IT network, and then you have jump stations into the industrial equipment. On the DMZ network, so to speak, on that you should have deployed honeypots. On whatever kind of networks, basically, as I normally say, if the network are producing something you care about, you would be able to put in the expenses for Honeypot. Again, back to being virtual, it might be not really that good thing. So basically, three things is that does you have some kind of remote access either from the IT network or even more interesting from like a 4G something else remote access? That would be the first thing. Does the network produce something you care about? And last but not least, put it, in a place where you said, okay, if you have very often people said, but I have like 300 substations, which one should I choose? And then of course go out and prioritize and said, okay, which one, if you put yourself in a moment in the attacker's seat, which one would you try to attack? Which one would be the most juicy target for you? Because it goes without saying, it's not necessarily everyone who have the opportunity to deploy honeypots on each network segment. So you have to choose and prioritize.
Thank you. Just a final question, very short one.
Sure.
You mentioned the ICS range, that the project you're working on. Is there a way I could, or anyone from the community, reach out to you and get access to this unique opportunity to train?
Yes, indeed. If you look into our website, angardesecurity.com, we have the item called ICS range. It's going to be available in November, but we are getting open for beta testing and early birds as well. So that's something I would love to give you access to.
All right. Well, thank you. Thank you, Mikael, for being here in the studio and for being here with the rest of the community. Thank you so much. See you very soon.
Indeed. Thank you.
Thank you. Thank you all for listening to the first talk of today. I do remind you, please do ask questions. We accept questions within the YouTube live stream and, of course, within our Discord channel, questions to the speakers. As well, please do remember to check out our really awesome webpage. It's not only the content that matters, but also the way how we present it. And check it out, and I'll be with you back very, very shortly in around 10 minutes for the next exciting talk. See you very soon.